This is still part of Unit 3, solving quadratics, but we're going to add one more final thing, and it's a combination of solving quadratics with complex numbers. So for vocab today, we're going to talk about the discriminant. The discriminant is the value of b squared minus 4ac. So based on your quadratic formula, we have a b squared minus 4ac. It's underneath the radical. That's considered your discriminant. Not with the radical, just what's underneath it. So the b squared minus 4ac. So for very important concepts, we have that if b squared minus 4ac is greater than 0, so think about the fact that it's underneath a radical. If it's greater than 0, you have a positive number. So if a positive number comes out underneath the radical, you have two real roots. And when we talk about roots, we also know that they're known as solutions or zeros. So that means that your graph, your parabola, your quadratic, will cross twice on the x-axis if there's two real roots. So if you have a positive value for b squared minus 4ac, if you do out the math and you get positive 40, you're going to have two real roots. If it's b squared minus 4ac, where what's underneath the radical is equal to 0, it's known as a double root. And so the double root means that it crosses the x-axis, not at all, it just touches it, it just touches the x-axis in one spot. So it could be here, it could be there, it could be reflected, but you only have that it touches the x-axis at one spot. And lastly, if b squared minus 4ac is less than 0, or is negative, right? If it's less than 0, it has to be negative. It means that you're going to have two imaginary roots. So if they're imaginary, they're on the imaginary axis, which is not part of your real x-axis. So they're floating up somewhere above or somewhere below if it's reflected, and will not cross the x-axis if in fact you have a negative number underneath the radical. Again, if there's a negative underneath the radical, we usually pull out an I when we're simplifying it, so that also stands for, and to kind of confirm that you have an imaginary number. For our two examples, we're going to find the discriminant and state the nature of the roots. So without even having to do the quadratic formula, you can determine if you have two real roots, one double root, or two imaginary roots. So b squared minus 4ac is my discriminant. A, b, and c are our values in standard form. So b squared would be 3 squared minus 4ac, a and c. And I simplify, that gives me 9 plus 56, which is 65. Because it's positive, going back to your chart, if it's greater than 0, you have two real roots, which means that somewhere it's going to cross the x-axis twice. You don't necessarily need to show that right now. We'll incorporate that as we go. For the second example, we have x squared plus 5x plus 11, where b squared minus 4ac is our discriminant. If I substitute in values for b, that's 5 squared minus 4 times a, there's an imaginary 1, times c, that gives me 25 minus 44, which is negative 19. Negative 19 is less than 0, so it's going to give us two imaginary roots, because I can't have the square root of a negative number without extracting that I.